Okay, so this will be part three of this chapter, which is chapter 22. We are going to finish it. And then, if we have the time, we might do some brainstorming. So, we already talked about the APCs and how they send cytokines or cytokines, which the process, we call it chemotaxis, if you still remember, which is a chemical attraction. And first they find the pathogen or the microbes or the foreign body, whatever it is, something that have foreign antigen, and it's going to phagocytose it, going to break it down, and then it's going to present this antigen to the rest of the immune system. So antigen recognition, the cells are going to come because of the chemotaxis that's happening. So the inactive cells are going to be activated by interacting with the APCs. There are some markers that are located on the different cells. These are different types, like CD3. It's we don't have to know like all the details. It's called cluster of differentiation, but that's not a big deal. It's just a marker that differentiate these different cells. Like 3 is in T cells, 8 in the cytotoxic and regulatory, 4 in the helper. So this is enough to know. CD are other markers. 4 on helper T. 8 cytotoxic and regulatory. So these are the CD markers located on the T cells that we need to know. So here are the CD8 cells, and these CD8 cells they activate by exposure to class 1 MHC. If you guys still remember, we talked about the major histocompatibility antigen, right? We have different types of antigen. So CD8, cluster of differentiation, or CD8, these markers, they should be exposed to the antigen on class 1, MHC, major histocompatibility antigen. And I talked about the perforin or perforin. The name gave it away. Perforin means perforation. So these cells, the cytotoxic cells, toxic to the cells. How they are toxic? They make an opening. They make perforation, and the chemical that you use is called perforin. It targets the cells so that the cells are open now and exposed, and then it can be decomposed and destroyed. This is how they destroy these cells. So this is what we do. We do antigen recognition by the APCs, antigen presenting cells. They recognize, and then they send by chemotaxis. They send these chemicals. CD8 cells will come, interact with class 1 MHC. It will be activated, and then it's going to divide, and it's going to interact with the different antigens. And in this case, they are destroying specifically our cells. This is how they destroy it. They make again, they secrete perforin, and this perforin is going to make an opening in the cells. The cells are going to be destroyed because the membrane that was surrounding it completely, this is a way to make sure that the cells are isolated and protected. Once you open it, the cells are gone. It will easily be destroyed. So this is how cytotoxic cells kill the cells that should be killed, the cells that we don't need, virally infected or whatever. Memory T cells, I talked about that before. We leave memory cells so that the second exposure is going to be easier, faster, and we secrete more antibodies. So you should remember this. What's the difference between first exposure and second exposure? This is the difference. The first exposure, you don't have memory cells. This is your first time ever to be introduced to that antigen. You didn't see it before. So you have no idea what's going to be your plan. So by the time you do the APCs, you recognize the antigen, you send cytokines, chemotaxis, attracting other cells will come, cytotoxic cells, they're going to make a perforation, killing the cells. At the end of this, we are going to put aside some memory cells. So next time we're exposed to the same antigen, these memory cells already remember the whole fight and they know exactly what happened. So that's explain the second exposure is shorter, you act faster, and you secrete even more antibodies because you know already what you need to do. You did it before. So this is the rationale of having these memory cells. And I mentioned before that the memory cells will have different lifespan. We don't have to know exactly what it is, but understand it has different lifespan. Some of them will stay for a week. Some of them will stay for a month, 6 months, for life, like I talked about measles. So this is all the memory cells. Regulatory cells, the name gave it away. It regulates. But remember this, when I say helper cells, when I say regulatory cells, okay, both of these cells are T, right? But does these cells help or regulate T? No, they help and regulate B and T. Clear? Just this point is important to remember. Even though it's called T helper cells and T regulatory cells, yes, but they help and regulate both of them, T and B. What do you mean regulate? Stimulate or inhibit according to the need. So CD8 cells, remember the CD8 cells, these are the cytotoxic. Now the CD4 are the T helper cells. T helper cells are going to secrete cytokines to attract even more cells. So remember cytotoxic CD8 and helpers CD4. This is their cluster of differentiation that they work with. Cytokines, the name gave it away. Cyto means cells, kines mean movers. Cytokines are the cell movers. These are chemicals. When you release it, it's going to move other cells. That's why we called it cytokines. There are a lot of these, like interleukin. What's interleukin? Inter means in between. Leukin means white blood cells. So interleukin is one of the cytokines in between the white blood cells. Interferon, I talked about it before. What does it do? It interfere with what? Viral, specifically viral what? Not infection. Something specific. Viral, interfere with viral what? Replication. Interfere with viral. Yes, it interfere with the viral infection, but how? By interfering with replication. I talked about that and I told you guys it's important to know. So remember it. Others are tumor necrosis factor. No explanation needed. It's called tumor necrosis factor. It kills the tumor cells. What's necrosis? Death. Yes. Some others are phagocytic activating chemicals, chemicals that activate the phagocytes. Some others are called colony stimulating factors. They stimulate the cells to make more colonies of itself. Here are the interleukin. The one thing that I want you to know is these are messengers, chemical messengers between the different types of white blood cells, specifically T and B. This is how they communicate. Interleukin in between the white cells. There are different types of these interleukin, but this is what we need to know. Tumor necrosis factor. This is a factor that's secreted and cause necrosis of the cells that have cancer or tumor. And it is secreted from the activated macrophages and cytotoxic T cells. These are the two cells that secrete those in order to kill the tumors. Does it really kill all the tumor cells? No, it just work on it a little bit. Other chemicals activate the phagocytes. Colony stimulating factors, again, these are secreted or produced from the active T cells in order to stimulate making more colonies of different cells. T cells, so this is all about the T cells, and I didn't talk much about it. This, what I told you, is the core that you need to know. Good enough. B cells, I mentioned it is antibody mediated immunity, meaning it does not involve, it's not involved physically, not as cells. They secrete antibodies. But before they can secrete antibodies, they need to change to what? Plasma cells. So what actually secretes plasma cells? But the plasma cells are B. Not exactly. It is mature B, activated B. You can't say plasma cells are B. That's it. No, it's not another name for B. It is not. It is the activated, matured B. B cannot secrete. Plasma cells can. So by doing that, they secrete antibodies against specific antigens, and these antibodies are going to kill the cells and destroy whatever the organism that's carrying this antigen. And there is start with sensitization first. They become sensitized to the antigen, and then they become activated, and they start to become plasma cells and release their antigen, their antibody, I mean, to fight the antigens. Helper T cells, I mentioned it before. Helper T cells, they help both T and B to be activated. So which virus invade these T cells? AIDS virus. AIDS virus. What happened when you destroy the T helper cells? B and T, both of them, they do not get help, so they will not be activated. So you're losing both of those. And this is what happened with AIDS. You cannot activate both of them, T and B. You don't have cell mediated, you don't have antibody mediated. What's the other name for antibody mediated? Humoral. Humoral. So you cannot activate any of them. So your immunity now is very weak, and any infection can cause major problems. Here are the plasma cells. I talked about it. The B cells become plasma cells before they secrete the antibodies. And just like the T cells, we also have memory B cells, just like the memory T. So at the end of being exposed to a foreign body, I should say, not necessarily infection, as if any foreign body. After you're exposed and after you do everything, including the APCs, macrophages, and then you activate T and you activate B. After all of that is gone, and you're fine now. The virus is gone away, and you're fine now. You are going to leave memory B and T, both of them. Antibodies. The antibodies that not the B cells, the activated B cells, which is called plasma cells, secrete. What's the nature of these antibodies? Which plasma protein is it? Does anybody remember? Globulin. What type specifically for globulin? Immunoglobulin. Excellent. Yes, immunoglobulin. So antibodies are immunoglobulins. This is their nature. And these antibodies, they have one pair of heavy chains and one pair of light chains, and each chain will have constant segment and variable segment. This is the structure of the antibodies, and just this is the physical structure: heavy chain, light chain, constant, and variable. That's it. This is generally speaking the structure of the antibodies. There are different types of antibodies, and this part is actually important. and you have to remember it. We have 5 different types of antibodies, and each one have specific characteristics that you need to remember. It is GEDMA, and each one of those have a specific characteristics that I want you to remember, and it is not all of this. It is exactly what I want you to know. If you come up with this, and if you memorize this, this is enough. And I will tell you how I remember it. It might help you. G, I always remember it with great, great amount. G is the first letter of this is not scientific. This is something just to help us remember. G remind you with great amount. So this is the most abundant type of all of these antibodies. This is one. Okay, and the other thing is this is also the one that go from the mom to the fetus. Since it is great amount, part of it go to the fetus. This is how you remember it. Okay, you have to memorize it anyway. You have to remember it. Two things: great amount. It is great amount. Since it is great, part of it go to the fetus. So it is the type of antibodies that go to the fetus. E. What I want you to remember about the E is this is how I remember it: allergy. E, allergy, as if allergy end with E. E, allergy. So when do we need those? In allergy. And which cells are responsible for allergy? Basophils. They secrete the two H's, right? But the most important is if you just memorize this word, E for allergy. Okay, I'm telling you what I used to. I know it's kind of weird a little bit, but this is what I used in medical school. I have to memorize like huge amount of information. You have to come up with something that stick in your brain somehow. Okay, so if that's not the case, find something for yourself. But you cannot just read. All of this is going to be mixed up in your head, and you will not remember it. So you should find a way to remember it. D is not something that's very important. It's just associated with the B cells. It helped sensitization. So that's good enough to know. Help sensitization. Me is for moment. This is how I remember it. Moment. Moment. This is the first one that appears in the blood. So we have 5 types, but this one is the first one that you release. And that's why I say M for moment, momentarily. It's the fastest one, the very first one to be released. So you should remember this. A, I remember it ASS. Okay, I'm not saying the word, but it's ASS. A, surface secretion. This is how I remember it. That's it. ASS. When you see A, you know it's SS. What's the S? Surface. What's the other S? Secretions. What do you mean? I mean, if you have any secretions in your body that contain antibodies, you should remember it's A. Milk, the mom's milk, yes. Tears, yes. Any secretions, yes. Any secretions. Surface, any surface. Like if you have a hollow organ and you have a surface like the alveoli or the bronchi, whatever the surface is, it is the type A. Okay? So this is what I want you to remember. Surface and secretion. Antigen, antibody A or IgA is for surface and secretions. So basically, when an antigen come to the body, it will be recognized first. And who recognize it? The APCs, including the macrophages and some of the T cells. They recognize it. We call that the APCs, antigen presenting cells. So what is this? Let's see. If this antigen is ours or it's foreign. I am programmed. All these APCs are programmed. They know already. They have a memory and they remember every single antigen in our body. Okay. So when they see something, they compare it against their database. Is it this? No, 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 no. It's foreign. We're going to fight. Fight how? Cytotoxic and humoral. We're talking about humoral now. So when the B cells get sensitized, they change and become plasma cells and they secrete antibody specifically for this antigen. That's why it's sensitized first. And then the antibody will go to that antigen and they mix together or they attach to each other. And we call that antigen antibody complex. Antibody coming from plasma cells go to the antigen, they mix with each other, they attach to each other, and we call that antigen antibody complex. Look at this. This is the whole thing here is a foreign body. And look at the yellow. These are the antigens. So look how the antibody goes specifically and make a complex with the antigens. There are types of antigen that we should have a little bit of information about it, which is complete or incomplete or incomplete. Complete antigen, it has at least two antigenic determinant sites, like this. You have at least two of those. If you have two of those, I call you complete antigen, and you can, as a complete antigen, you can start the process right away, immediately. Once you go into the body will start the process against you, and all what we talked about, APCs followed by B cells, antibody, and the T cells, cytotoxic, all this process can start if this is a complete antigen. So do you mean there is incomplete antigen? Actually, there is half antigen. So complete antigen has two determinants, antigenic determinant, which is the one that if you are exposed to, you can be sensitized and you can start the process. You can be maturate to plasma cells, secrete the antibodies, and you start the immune response. However, there is another one that's called half antigen, and we call it hapten. And it is coming. Um, Hapten basically is half antigen combined. Hapten. Okay, half antigen. They just put it together into hapten, and hapten is half antigen. And I will talk about it. I'll give you examples. So what the antibodies do, they work in different ways. In all cases, they need to interact with the antigen anyway, the specific antigen. And they start the process of neutralization. They neutralize the antigen so it doesn't cause more damage. And then they can do some precipitation and agglutination when they make the complex, when the antibody go to the antigen and they mix together. And then here is another one, another antigen. It will come with this one and another one come together. So it make kind of like a lump. And this lump is called agglutination. And this, because it's big, it's going to precipitate and it will be easy for the complement to come and for the phagocytes to come and deal with it, destroy it. This is what they do. Did you get the idea? Antibody doesn't just go to the antigen and that's it. No, they go to the antigen and neutralize it. This is one. And also another antibody go to another antibody, and they come together. All of these they come together, making like a lump, making like agglutination. Agglutination means collection. They come together, and because they come together like this, they precipitate. And when they stop, they are not running. They stop. This will be an easy target for complement system to be activated and help the antibodies, and also to activate the phagocytes to come and eat this complex that you just made. They also help with opsonization. I talked about this before, which make phagocytosis easier. Here is the hapten talked about. Hap is half or hapt. If you put hapt antigen, if you mix it together, it's a big word. It's not hapt antigen. No, just to squeeze it together, it will become hapten. Hapt is half. So this is half antigen. What is that? It does not have the full thing. It's a partial antigen or half antigen that does not provoke the immunity by itself. It does not have the minimum of two antigenic determinants. So this antigen cannot provoke. So if you get it, you're not going to start the immune response. You're not. Then what's going to happen? What happen is it comes, it is antigen anyway, but half antigen. There will be some antibodies attached to it, and that's nothing so far. until this complex goes somewhere and starts a process when it is fixed on a surface. And the example of that is penicillin. If you have allergy to penicillin, you know what's going to happen if I give you a shot of penicillin or something? The penicillin, you have allergy, so you're supposed to provoke the immune system and work against it, right? No, it doesn't work like this. The penicillin goes into your blood and nothing happened yet. And then antibodies will come, B cells come, produce a little bit of antibodies. And when you make that complex, still nothing. This complex will go somewhere on a surface, stick itself, and start the process from there. Okay, so this is not a complete antigen, and you need to remember this example. It's not a complete antigen. It does not provoke the immunity, the full immune response by itself. Okay, it go through this process, and the example here is penicillin. So this is a complete antigen. Look at this complete antigen. It provoke the process, but the hapten does not. You have to have a carrier. You have to have antibody that can come with you when you have the carrier, which is one of the surfaces that will make it a complete antigen later on. Primary response and secondary response, I talked about that already. The first time that you're exposed to something, a foreign body or a foreign antigen, is called the primary exposure or the first exposure, and your reaction is primary response. Second time, it's called the secondary response, next exposure. And obviously, you already know the game. You already know what is this. You already know what is the plan, how to deal with it. So again, your reaction is going to be faster. It's going to be more extensive and more prolonged. And all of this because of the memory cells. That's the difference between the primary response and the secondary response. And it's not only the memory cells. There's another thing. So memory cells are the reason that the second response is easier and faster and stronger and stay for longer time. All of these good things are because mainly of the memory cells. But not, this is not the only thing. There's something else that's called antibody titr or titer. Antibody titr is the antibodies that are produced and going to involve in a fight. Not all of it go away. As if we don't call it memory antibodies. We don't. That's not scientific. As if it is memory antibodies. Did we get the concept? Some of the antibodies, not all of it involved. Some of it stay. Okay. And this antibody titer is going to, during the fight, it's going to go up gradually. And then when you're done, not all of it goes away. Some of it is going to stay. And the antibody titer is one of the diagnostic tests. If we want to diagnose something, we can find the antibody titer. And if we find it high for something, it's in the middle of the infection. When it starts to go away, it's still there. But when it starts to go down, it means you are recovering. Okay. So if somebody's having hepatitis, for example, how to diagnose this? There are several ways, but one of them is the antibody test. Let me get some of your blood sample. Let me see the antibodies and see how high it is. If it is very high, I tell you, you are in the middle of the infection. You are in acute phase. And if it goes down, it's going to be you are recovering, but some of these antibodies stay, and it's going to help in the second exposure if it come before it disappears. Primary response is IgM, right? Remember I told you M, momentum or momentary. So this is the one that starts right away, the first one to start. That's why it's responsible for primary response. Okay? G, great amount go to the baby. And this is the one that stay longer. So it is for the secondary response. So secondary response, um, this is your second time or more than one time, not necessarily second time that you're exposed. And if that's the case, M starts, but G will continue with you. And we have the memory cells to help us tell what should we do. Immune competence. Immune competence, by definition, is your ability to produce immune response after exposure to the antigen. Isn't that something normal? Yes, but some people are not immunocompetent. They might have an issue with one of these that we talked about, and it's called immunoincompetence. So immune competence means normal. If you're exposed to antigen, you start your immune response and everything goes just fine. And it's because of all these that I talked about already: the APCs, the B cells, the T cells, the antibodies, the ANK, the cytotoxic, all what I talked about so far, everything is okay. Everything is working fine. If there is an issue with that, then you are not competent. Bacteria versus virus, basically, most of it's almost the same. The main difference is the viral infection go into the cells and take over the cells and control the cells. So cytotoxic cells are the one, and natural killers are the one that deals with it. Natural killer, basically. And the bacteria will need, beside the APCs, it's more of cytotoxic cells. You guys can look at these pictures if you want to, but what I'm telling you is what you need to know. Here is IgG versus IgA. Look at this. Mother's milk, A. Maternal, G. You guys need to remember this. Glucocorticoid. Glucocorticoids, we talked about those in the endocrine system, if you guys still remember. And glucocorticoids have a couple of antis. It's anti-inflammatory, anti-allergic, and it's not this the third one. I just make it up just to help. It's anti-immunity. It's not really anti-immunity, it's immunosuppressant. Okay, so anti. These are the three that you need to remember: anti-allergic, anti-inflammatory, anti-immunity, meaning it's immunosuppressive. Remember the three antis. So does it suppress the inflammation? Yes. If you have severe inflammation, did you ever see, like, or you have this issue that you have like a lot of pain in your back and sometimes they give you a cortisone shot? Did you see that before? They do it because it is the strongest known anti-inflammatory. If somebody's having allergy, that's really strong allergy, what they give them? Glucocorticoid. Like allergy, they have like buffness and they can't breathe and stuff. They give them epinephrine first because this is life saving. But the rest, glucocorticoid, it's anti-allergic. The third one is immunosuppressive. Why do you want to suppress the immunity? Yes, sometimes you need to suppress the immunity. Examples: if you have hyper reaction or exaggerated reaction to the allergy, what should I do? I should suppress your response. You go outside for in the backyard or something, and or a bee, or you're exposed to something, poison ivy, whatever it is, and you get your allergic reaction. That's bad. Did you ever see this before? Like having all these red patches and swelling and that stuff. If you saw that, this is severe. So if that's the case, it is super reaction. The reaction is exaggerated, so we give glucocorticoid to suppress that, and because it's not needed. Why do you need to react all of this just for pollens, for example? Pollens in the backyard. Why should you react that much, right? This is unreasonable. This is exaggerated response. So we can give you immunosuppressive. The other thing is for organ transplantation, for example. if I give you, if you're, this is something routine, by the way. Anybody who's getting any type of transplantation, automatically they give them cortisone or glucocorticoid. It's immunosuppressive. It suppresses our immune system temporarily until the body gets used to this. Okay, they give you different medications so the body starts dealing with the kidney. It does not attack it right away because you're suppressed, right? All these T and B that's going to attack, we suppress them. Just leave it alone for now until your body start to get used to it, and then they go down slowly. So there are different reasons, but the bottom line is anti-allergic, anti-inflammatory, anti-immunity, or immunosuppressive. Immune disorders. We're supposed to have normal immunity, normal reactions to everything, right? If you have exaggerated reaction to an allergen, like me and you go to the backyard, there are a lot of pollens. I get a little bit of like itching, maybe, and that's it. But you start to sneeze and you get congestion and you get red patches or something. I am normal, but your reaction is exaggerated. You are hypersensitive. You're not supposed to be that much sensitive. So we call that hypersensitivity, and the name is allergy. This is one. Next one is autoimmunity. Autoimmunity, auto means self, right? Autoimmunity, self, immunity. You have immunity against yourself, which is exactly what I told you before, that your immune system have a memory, right? Everything is there. This is my liver cells. This is my skin cells. This is my joint cells. How to know it? They memorize all the antigens for all the cells. When I see any one of these cells, I look at the antigen. It's mine. Leave it alone. For some unknown reason, they don't know until now. They are still studying, but whatever the reason is, you get some sort of loss of memory to something, one or more. It doesn't have to be one. It can be more. It can be one or more systems. So, example, your immune system remember everything except your pancreas, specifically the islets, specifically more the insulin producing cells. Like I see all these antigens for all types of cells, everything I remember it, but I forgot this one. Its memory is lost for this one. So I go to these insulin producing cells in the islets of Langerhans of the pancreas, and I look at the antigen. What is this antigen? That's not mine. It's not in my memory. It's not in my program. So since it is foreign, I need to attack, destroying the insulin producing cells, and this person end up getting diabetes, right? Make sense? Thyroid. Yes, sometimes you just forget the thyroid. How about everything else? No, I remember everything. I forgot the thyroid. And I'm going to go to the thyroid, attacking the thyroid, something called Hashimoto thyroiditis, for example. You attack your own thyroid. A very famous example, sometimes our immune system attack our joints, like rheumatoid arthritis, right? We hear about this? Rheumatoid arthritis. Your system remember everything except cells of these joints for some reason, attacking this, and so on. So these are the autoimmune disorders. And the last one is immune deficiency. Something in all of these that we talked about is deficient, one or more. Just by the way, for the autoimmune disorders, it doesn't have to be one system only. It can be multiple system, and this is a very unfortunate person, like systemic lupus. Did we hear about this? The SLE, systemic lupus erythematosus. Systemic lupus is not one. He forgot your system, forgot your skin, and forgot your blood vessels, and forgot your joints, and forgot your kidney. So it's going to attack all of these. And that's why it's called systemic. Okay? Lupus. It means it's systemic, it's many parts, not just one. Immune deficiency is one of these, is deficient. Allergy, which is hypersensitivity, it's four types. Type 1, 2, 3, 4, immediate, cytotoxic, immune complex, and delayed. Immediate. This is the one that I always refer to. You go to the backyard, few seconds, a minute. This is immediate, right? It's few seconds. And you get this allergy. So this is uh, type 1, which is immediate. And the example that you have to remember is allergic rhinitis. Maybe you're not familiar with this term, but this is exactly what happened if you go, for example, in the backyard or outside or something, and you get your nose, everything is in your nose, right? You start to sneeze, your nose is congested, right? Did you have this before? This is called allergic rhinitis. It's allergy in your nose. Rhino means nose. So allergic rhinitis is an example of immediate hypersensitivity, which is type 1. And which antibody is involved here? Which one? In this allergy. M is for what? Moment. So this is the one that's, somebody said it. E. Yes. Allergy. E. Allergy. So it's E. A. ASS. Okay. Surface and secretions. E. Allergy. G is for great, and it go to the infant and secondary response. Don't forget this. Okay. I'm giving you the minimum that you have to remember. Remember it. Write down all of this, all of these abbreviations or whatever, the way you remember it, but you have to remember it anyway. One more thing that I want you to know here is what I just mentioned is a mild type. Like what's so bad about going out and you get some congestion and you sneeze a little bit? Yes, it is hypersensitivity, it is allergy, but it's not too bad. Some people will have severe form of that, and we call it anaphylaxis. Example, a bee sting. If you get a bee sting, it's bad, right? It's painful, itchy, and that's it, right? But some people will have exaggerated response. It goes to the severity to that they cannot breathe, they get bronchospasm, right? And blood pressure drops dramatically, they get shock, and we call that anaphylactic shock, anaphylaxis. And for that reason, if one of your friends or family or something have an issue like this, they go with the EpiPen. Did you see it before? They carry it all the time. If something happened, just to take care of the the uh, the severe part, which is bronchoconstriction and hypotension. This can literally it can lead to death. That's why they always carry this EpiPen. Okay, it's epinephrine basically, and epinephrine is sympathetic or parasympathetic. Sympathetic. So does it dilate or constrict? Dilate, isn't it that treatment? It is a treatment. So that's why they go with the EpiPen all the time, and we call that anaphylaxis, severe type 1. It either go away by itself or there is something called desensitization. They give you like a complete analysis. It's like a big problem. They go like in your the back skin and give you like 100 different types of allergens, all known allergens basically, and they see your reaction against which one, and then they start to expose you to very small doses of this, and it goes gradually. That takes time, but it desensitizes, and some people, for some unknown reason, they just desensitize automatically. We don't know how. Yes, it can develop. It's not very clear. You can have it and then goes away, or you don't have it, and then when you are an adult, you develop something you don't know. It's just changes and I think it has like genetic roots into it that bring it later, or you have it early and then it goes away, or continue. It's very unexpected. Nobody can tell. Basically, nobody can tell. They can tell you, maybe you can grow out of it. Are you sure? No, I'm not sure. I don't have any allergy. Maybe when you grow up, you will get allergy. Maybe. Can you know for sure? No, you cannot know. There is no way to know. Okay. So this is the anaphylaxis that I talked about. And anaphylaxis is exaggerated reaction of type A. Most important thing to remember. Bronchoconstriction, shock. What's shock? Sudden, severe drop of blood pressure. Clear? These are the most important two. Anaphylaxis. Antihistaminic is something that can be used in that case, and basically it's dealing with this. So let's say it this way. What do you think happened when you go to the backyard and get that sneezing and congestion? This is histamine, right? Because basophils are involved in allergy, and I just talked about it. They secrete histamine and heparin. Do you remember this? So histamine is going to dilate the blood vessels, and this is how you get the congestion. I give you antihistaminic, it goes away if it is something minor. So if you get this, what can you do? Just take antihistaminic. How about the cortisone? No, it's not bad enough to get the cortisone. Cortisone is very strong anti-allergic. So they can give something antihistaminic like the very famous Benadryl. It is just antihistaminic. And what happened when you give antihistaminic? Histamine decrease. So the vasodilation that was happening because of the histamine goes down, constriction, and you get rid of the congestion that's bothering you. Autoimmune response, you secrete autoantibodies. B cells secrete autoantibodies. Here are the three examples that I talked about. Thyroiditis, you only forget the antigens of the thyroid and you attack thyroid. Rheumatoid arthritis, you attack your joints. Type 1 diabetes, you attack the islet cells that secrete insulin specifically. The worst type of immune deficiency is severe combined immune deficiency disease. In this case, those people or those infants usually they die because it is too bad. It's called severe combined. So it is severe, this is a degree, and it is combined, like everything is affected. BNT, humoral or antibody mediated and cell mediated. Okay. So this severe combined immune, and how is it severe combined? Like in case of AIDS, why is it severe combined? Because the AIDS attack helper cells, and helper cells are the ones that activating TNB. If the helper cells are gone, you don't activate TMB. So which type do you lose? Both of them. That's why we call it combined. This is not the only reason. This is one of the well-known reasons. Others are immunosuppressive drugs. Do you mean glucocorticoid? Glucocorticoid is the most famous one. But there are other medications, and I don't have to go into the details, but there are some other drugs that suppress the immunity as well. Aging, everything deteriorates, thyroid becomes smallest, sensitivity decrease, cells are production of cells decrease, immune surveillance decrease. What is the immune surveillance? Which cells? NK. Yes, NK. And okay, that's it. This is just linking these systems together, integrating the systems, but we got what we need to know.